Hello one and all, and welcome to the Math Magic Show. In this one, let's take a look at some basic or perhaps elementary examples of using summation notation. So, as a first go, imagine that we have this list. Now this list has the values 1, 2, 3, 4, 5 being added up. When you look at a list like this, to make summation notation work, you gotta observe some key characteristics. One of these key characteristics would be the starting value, which in this case happens to be 1. And then you also want to observe things like, for example, from 1 to 2 is 1 more, you see? And then from 2 to 3 is another 1 more. And from 3 to 4 is another 1 more, and so on. Until you get to the stopping value, which is, as you can see there, positive 5. So the 1 would be the starting value of our index, and the 5 would be the stopping value of our index. These are all little things you have to observe. So that means the following. In summation notation, it will look like this. On the bottom, as you can see, we have that 1. And then up here, across the top, we have that 5. And the n simply represents each value in the sum there. So n is at first 1, then it's 2, then it's 3, then it's 4, and then it's 5. So that's how you can convert a simple list into summation notation. Sigma, in other words. Let's look at some additional examples. So now imagine that the goal, just because we feel like it, is to convert everything from the 2, the 3, and the 4 into sigma, but keep the 1 and the 5 on the ends outside the sigma. How do we do that? Well, again, you gotta always make the same key observations. So the key observation for the starting value would be 2, and the stopping value there, as you can see, would be 4. And it's gotta go through the values 2, 3, 4. So let's rewrite this. It'll basically look like this. Let's go through this a little bit. So what I observe is that the 1 there, as you can see, stays. And then put a sigma right between the 1 and the 5. You can do that because it really just represents the addition of the 2, 3, and 4 anyway. And then what stands out perhaps about this is that on the bottom, the starting value of the index n is 2, which is the starting value of the 2 there in the list in green. The stopping value across the top, as you can see, is 4, which is also the stopping value. It's the red 4. The n represents the values from 2 to 3 to 4 in turn. And then the 5 is just copied because it's just an extra value at the end. So you can put these symbols just somewhere in the middle between two numbers, because in the end it represents just addition. That's all it is. Let's look at this example that says 1 plus 2 plus 3 plus 4 plus 5. And the goal is to keep the 1 and the 2, but somehow take the 3, 4, 5 and rewrite that using sigma notation at the end. Just for practice, so you can learn to manipulate that symbol so it doesn't seem like some unbreakable brick. Okay? It's very fluid if you know how to use it. So let's take a look. What I'm going to do is as follows. I make some key observations, which is that you see that green 3, that becomes the index, and that red 5, that becomes the stopping value of the index, and then because it has to go 3, 4, 5, I put a variable like n after the sigma. So these are all examples of placing the sigma symbol pretty much any way you want. Let's take a look at some additional examples. Now let's take a look at something a little bit different. Imagine I have the list 1 plus 2 plus 3. With sigma notation, it would be from n equals 1 to n equals 3, and you would be adding up the value of n essentially. But imagine as a small puzzle that what I want to do is write it this way now. So what I have here is that the stopping value of index should be 2, and on the bottom I want the starting value of the index to be 0. Let's think about the values. N is 0, n is 1, and n is 2. So what is true is that there are still 3 values, which is good because we have 3 numbers we need to add up. The only difference though is that, for example, n equals 0 no longer corresponds to the 1. And for example, the stopping value, which is 2 in the top, that no longer corresponds to the 3. So there's some kind of issue happening here. So then the question is, how do you take that expression, which in the previous examples was just n, and rewrite it so that it still represents the same sum? So let me state that one more time. How do you write the expression, which in the previous example was just n, so that it still represents the sum 1 plus 2 plus 3, but the indexes are changed? And the key is to observe the following, that when you move the indexes back, so what I mean by that is this. In the previous example, the index went from 1 to 3. In this one, the indexes go 0 to 2. So it looks as though the index has been moved by 1 back, okay? So for example, 1 minus 1 on the bottom is now 0. Across the top, we had 3. 3 minus 1 is 2 now, you see? So it's almost as if you were subtracting 1 from the index relative to that basic example that we did. What you do to modify the expression that you're actually going to add up, you do the opposite. So in other words, since here you're decreasing the index, the expression you increase as follows. It'll pretty much look like this. So you're going to have here n plus 1. So let's see whether this actually works or not. You can always check as follows. what I have then on the bottom is the stopping index is 2, the starting index is 0, and the expression is n plus 1. Don't forget the goal. The goal is to make sure that once I expand this, write it out, that it's still equal to 1 plus 2 plus 3. So I've shifted the index 1 back, which means the expression is modified accordingly by adding 1 to 1. In the opposite direction, so to speak. Let's go through that process. So when I do that here, I will have the following. You see, for example, below me you see n equals 0. So when n has the value 0, we end up with 0 plus 1. Then when n has the value 1, we end up with 1 plus 1. When n has the value 2, then we end up with 2 plus 1. And once you can simplify these quantities within parentheses, what do you observe? Look carefully. You have, again, 1 plus 2 plus 3. And that confirms that by writing the index at the starting value as 0 and the stopping value as 2 indicates that you got to take the n and add 1 to it, not subtract 1 from it. So the way you modify this expression that I'm next to is the opposite of the way you modify the index. The question, of course, is there a reason for that? Some technical reason, than something more than just I'm telling you that it's that way, okay? And believe it or not, there is, and it's a relatively simple one. If you might remember the graph transformations, like when you move right, you do like x minus 1 within parentheses, or when you move left, you do like x plus 1. It's the same thing here, okay? So let's see. So now let's take a look at that technical reason in a bit more detail. So what I'm doing is, since my goal is to go from 0 to 2 and not say from 1 to 3, it's as if across the top I did 3 minus 1. Across the bottom there now I'm doing 1 minus 1, which means that this expression n is modified exactly the same way by doing n minus negative 1. That's the key. So in all of these cases, you always basically have the variable and you subtract. If you're moving the index to the left by 1, then here you would do minus negative 1, which once you simplify it, well, n minus a negative 1 will give you n plus 1. On the bottom you have 1 minus 1, which is 0. Across the top you have 3 minus 1, which is 2. And this then will give you what you want. This. It looks clean now. That's a technical note. Let's look at one last example of this process. So again, our list is 1 plus 2 plus 3. And now imagine that what I want to do is, the goal is to rewrite this expression, but so that it goes from 2 to 4, say instead of 1 to 3 or 0 to 2, or something along those lines. So when I look at this, I hope you observe that the starting index is now 1 higher. And then the 4 is also 1 higher than the 3. So what I mean is, instead of n being 1, which is the way it would be for the simplest possible summation notation, n is now 2. And that's 4 instead of 3 in the top there, okay? This is a red 4. It looks as though the index clearly has increased by 1. And remember what I said, that when you do this, when you grow the index, you would now shift the expression. In other words, you would subtract 1 from n. So in the previous example, when you took 1 from the index, when you subtracted 1 from the index, you added 1 to the expression. Here, because you're adding to the index, you're going to subtract 1 from the expression. The opposite. Let's actually see whether this works or not. Don't just believe what I say. So this is n minus 1. That's the new expression. And let's look with the piece on the bottom there. Let me enable the pieces and let's talk about them. So I'm adding up here the following. I have n minus 1. So when n first has the value 2, which is the starting value of the index, you have 2 minus 1. And then next would have the value 3. And lastly, n would have the value 4. Now when you simplify these, look at what happens. Go back to the first one. 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. So as you can see, that list that we generate on the bottom, that sum 1 plus 2 plus 3 is the same as the one across the top. So that's working as expected. Is there some more technical reason for this? Yes, I guess if you want to think of it as such, then you might understand it this way. By saying that I want the starting index to be 2 and the stopping index to be 4, I'm essentially adding 1, if you think about it, to the indexes. So in the bottom now, it's as if I were doing 1 plus 1. And across the top, it's as if I were doing 3 plus 1, correct? So I'm growing the indexes by 1. What you do is the following. But as I said in the last example, when you modify the indexes, you modify n, which is kind of the variable, always the same way. You put, for example, n minus, and this time, because we're shifting by 1 to the right, you're going to do n minus positive 1. In the previous case, because we were shifting to the left, I did n minus negative 1, which ended up being n plus 1. So this is a slightly technical note here for those of you who are interested in understanding things a bit more deeply. So once you clean this up, it will look like the following. The starting index is 2, the stopping index is 4, and the expression, once you clean up n minus plus 1, it's just n minus 1 in the end. And this is exactly as I said it would be. Okay, that is it for me. Thank you so much for watching. Please leave a like and subscribe, and I will see you in another video.